We've been looking at linear equations in several forms recently. For example, we've looked quite a bit at slope-intercept form, and then in the last section we looked at point-slope form. Now we're going to look at standard form, which actually we've seen before. But as a review, standard form will have this appearance where we have ax plus by equals c. So in other words, the x term, the y term are on the same side of the equal sign, and then we have some constant on the other side of the equal sign. A, B, and C are all going to be real numbers, and we also have this little qualifier that A and B cannot both be 0. One or the other could be 0, but not both at the same time. So having already worked with that and seen the form here, we're going to go ahead and dig into some examples. In the first one, write two equations in standard form that are equivalent to 3x minus 4y equals 6. Notice this is already in standard form, but we can write an equivalent to this by simply multiplying both sides of the equation by the same number. And you get to pick what number that is. So for example, we could multiply each side by 2. Now notice that we get 6x minus 8y equals 12. And if you were to graph this equation and then graph this equation, you'll find out they're the same line. So that's an equivalent equation. It looks different, but it's equivalent. We could also multiply by, let's say, a negative number. So let's take 3x minus 4y again. And how about if we multiply that by negative 3? Which means we have to also multiply the other side, or the 6, by negative 3. Now if you wanted to get it crazy, you could multiply by some fraction, you could multiply by some decimal, just multiply to your heart's content here, but make sure you're multiplying each side of the equation by the same number. So negative 3 times 3x will give us negative 9x, and then negative 3 times negative 4y would be plus 12y equals 6 times negative 3 is negative 18. And notice that because you get to pick the numbers that you're multiplying the equations by, you could really have an infinite number of answers here, but they should all be able to simplify to this original equation. Okay, number 2, write an equation in standard form of the line shown. So here we have a line on a graph. We're given two of the points on that graph, 3, 3, and 3, negative 5. So what you're going to find here is very often in standard form, we're going to start with our equation in some other form, such as slope-intercept form or point-slope form, and then we're going to rewrite the equation into standard form. Okay, so in this case, when we have 2 points, we have to calculate the slope. So this is going to be y2 minus y1 over x2 minus x1. So this is going to be, and it doesn't matter, remember, which one you call point 1, which one you call point 2. Let's call that one point 1, and we'll call this point 2. So for the change in y, we get 3 minus negative 5. And then for the change in x, we have 3 minus negative 3. Which gives us 8 over 6. And of course we notice that we can simplify that to 4 over 3. And now we have to decide, do we want to use slope-intercept form first or point-slope form? And you might spot here, well, it looks like that's a pretty clear slope-intercept, or pardon me, y-intercept of negative 1, so you could use that. Or we could just go ahead and use one of these 2 points for point-slope form. And if I do that, let's go ahead and use this point, 3, 3. So remember that for point-slope form, we have y minus y1 is equal to the slope times x minus x1. So we would have y minus 3, because the y-coordinate is 3, is equal to, our slope is 4/3, so 4/3 x minus 3, because our x-coordinate here is also 3. So now I'm going to apply the distributive property. Y minus 3 equals 4/3 times x is 4/3 x. That's a 3. And then 4/3 times -3 is a -4. The 3 here will cancel the 3 in the denominator. We just get -4. Now we want x on the same side of the equation as y. So I'm going to subtract 4/3 x because that's a positive 4/3 right now. So we have to subtract that from both sides. And that gives us -4/3 x plus y. That was a positive y, so it's still plus y minus 3 is equal to -4. Don't forget the negative there. And then our last step is we have the x term, we have the y term, we want everything else over to the other side, so I'm going to add 3 to each side, and that will move that last constant over to the right, and we get -4/3 x still, that didn't change, plus y equals, and then -4 plus 3 is -1, and there's our equation. So notice we wrote it first in point slope form, and now we have it in standard form. Number 3, find the missing coefficient in the equation of the line shown. So here we have the form ax plus y equals 1, which is standard form at least once we determine the value of that coefficient a. So we have ax plus y equals 1, and fortunately we have a point here where we can get the value of x and y. So I'm going to substitute the value of x here. So we have a times -1 plus, and then substitute the value of y in that same point, plus 4 equals 1. Now we can solve for a. So a times -1 is -a plus 4 equals 1. And then we want to undo this addition, so I'm going to subtract 4 from each side. And we still have -a. These undo each other, and we have -3 on the right hand side. And then we don't want the opposite of a, we want a itself. So I'm going to divide by -1 to get rid of that negative sign. And then that gives us a is equal to -3 over -1 is 3. So for this particular equation, we're done because we found the missing coefficient. It is 3. You might see a problem similar to this where the directions say write the completed equation once you know the coefficient. So then we would take that value and substitute it back into that equation and write 3x plus y is equal to 1. Alright, moving on. Number 4. Write the standard form of the equation of the line with slope 3 and passing through the point for -2. So this is set up very nicely for point slope form. So I'm going to say that y, and then because that's a negative, remember that switches to a plus 2, is equal to slope of 3 and then x minus the x coordinate here of 4. And I'm going to go ahead and apply the distributive property. You get y plus 2 equals 3x, and then 3 times -4 would be -12. Then I want the x term on the same side as the y, so I'll subtract 3x from each side. So we have -3x plus y plus 2 is equal to -12. And let me rewrite that up here so I don't run out of room. -3x plus y plus 2 equals -12. And then we have our x term here, we have our y term, we want that constant moved over to the right side, so we will subtract 2. On the left hand side we have -3x plus y equals -14. And there's our equation in standard form. Alright, so this might remind you a bit of section 3.8 where we were rewriting equations. Notice that in the last example we rewrote the equation first in point slope form, and then we rewrote that in standard form, and we're going to do something similar here. Write the standard form of the equation of the line that passes through the points -1, 2, and 3, 4. So first we're going to have to find the slope. So if we look at that as 0.1 and this is 0.2, remember it doesn't matter, you can flip that around. We'll take 4 minus 2 for the change in y, and 3 minus -1 for the change in x. And that will give us 2 over 4, which simplifies to 1/2. So now we get to pick which one of these 2 points do we want to use, and it doesn't matter. Let's go ahead and pick, let's go with 0.1. So then we have y minus 2 is equal to the slope of 1/2, and then x minus -1, which is the same as x plus 1. Apply the distributive property here. So we have y minus 2 equals 1/2 x plus 1/2. Then I'm going to move the term with x over to the left hand side. Because that's a positive 1/2 x, we'll subtract 1/2 x from each side. So it becomes negative on the other hand, or on the other side of the equation. So we get negative 1/2 x plus y, since that's positive, minus 2 equals 1/2. And then our last step is to move that constant, the -2 or the subtracting 2, to the other side of the equation. So we'll do that by adding 2. Okay, and now of course, well, let's start with the negative 1/2 x plus y on the left hand side. Of course, if you're lazy, you might just say, well, 1/2 and 2, that's 2.5. Or you could say that 2 plus 1/2 is the same thing as, let's get a common denominator here, 2 over 1 is the same thing as 4 over 2. So we could write that as 4 over 2 plus 1/2. So we have our common denominator, we'll keep that. 4 plus 1 is 5. So we have negative 1/2 x plus y is equal to 5/2, which is generally what we'd prefer to see here. Go ahead and leave it as a fraction, even if it's an improper fraction. Okay, and number 6, here we have an example of where standard form might make a little more sense than the previous examples. In the examples we've looked at so far, it might seem like standard form is extra work. We don't really need it. It's not doing anything for us. But let's look at this example. A group of people goes to a movie and pays a total of $68 for tickets. If the admission price is $8 for adults and $5 for children, write an equation that shows the relationship between the numbers of adults and children in the group. So what we can do here is use A to represent the number of adults in this group, and then C will represent the number of children in the group. So in this particular case, we don't know, because we weren't there, how many adults, how many children there were. But we do know that for each adult they had to pay $8. So the money they spend there can be represented by 8A. And then the money that they spend on the children can be represented as 5C. So here we have $8 for each adult plus $5 for each child will give us our total cost, which was given to us here as 68. Alright, so there you go. Again, I hope you're comfortable with rewriting equations, because you will be doing a bit of that in this section, and I hope you enjoy standard form.